On number 10, I'm trying to solve the system of nonlinear equations by the elimination method. So my goal is the same as my previous problems, but instead of using graphing and instead of using the substitution method, I'm now using the elimination method. And it's very similar to the elimination method for linear equations. I'm trying to eliminate one of my variables. So if I multiply the top equation by -3, then that's going to put a -3x squared here, which will eliminate with this positive 3x squared. So I want to add these up, and those x squareds go away, and I have a 22y squared is equal to 22. So y squared is equal to 1. So y is equal to, if you take the square root of both sides, plus or minus square root of 1, which is just plus or minus 1. So I have y is equal to 1, y is equal to -1. Now I need to plug these both back into one of my original equations. And I'll plug them both into the top one. So I'm going to go up here, so the top one will be x squared plus y, but I know what y is, it's 1. Squared is equal to 26. And x squared plus -1 squared is equal to 26. So this will be x squared plus 1 is equal to 26. X squared is equal to 25. And then I want to take the square root. And whenever you take the square root of both sides, you do need to put a plus minus. So x is equal to plus minus 5. So from the branch of y is equal to 1, we actually have two different solutions. We have 5, 1 and -5, 1. Now looking at the other one, this is going to be x squared plus 1 is equal to 26. If I subtract 1, I get 25. If I take the square root of both sides, it's going to be x is equal to plus or minus 5. And that gives us two answers here as well. So we have 5, -1, and -5, -1. So if you check out all four answers in both of the original equations, they work. So we have four different intersection points here, and those will be our answers.